like that. We're going to talk a little bit about shoving things into vector databases here, but we're going to talk about how you can do it in real time and in Python. And we're going to use Bytewax, which I'll talk a little bit about in a second. And I am more than loosely affiliated with Bytewax, and that's why I'm wearing this B-esque shirt here. So we all love the new power of large language models. Probably all been playing with them or building things with them. And we've probably all noticed that they do have a little problem. For example, I want to find out what the new Barbie movie grossed and who are the main actors, but unfortunately that was after the cutoff. So the problem is that the language models themselves are stale. Stale isn't bread. Nobody likes stale bread. If you serve stale bread to your customers, they will leave. If you serve stale data to your customers, they will also leave. So in our instance with the Barbie movie question, we would probably leave ChatGPT. Well, maybe not because of future changes, but we would leave ChatGPT or we'd leave the large language model application and we would go back to Google to find out what happened. Now, I know what you might be all thinking in that I've made this before the OpenAI dev talk and RAG is obliterated, et cetera, et cetera. I don't think it is, but I just wanted to address this. In the instances where you were using ChatGPT to do that, it would look up in Bing and provide you some context and answer that. And we'll talk about that in a second. But in most applications specific to the large language model itself, you're still going to come upon this RAG problem. So we'll ignore the OpenAI dev day for right now. So a little bit about me before we start continuing on here. So I work on Bytewax. If you want to head over to Bytewax/Bytewax and give me a star, that would be amazing. Thank you. I'm also sitting right in front of this room for the rest of the conference. So if you want to talk about anything or if you want me to make you a pour-over coffee, I'm making pour-over coffees because conferences always have really bad coffee. No offense to the to the conference organizers, whom Ollie, who is part of my team, was a part of. It's just a fact. When I'm not working on Bytewax, I'm also a dog and now a human dad. If you are starting a new company, don't have a kid. It's really hard. Outside of work, I like to go skiing and generally get outdoors. This is me, mostly trying to look cool, but also trying to go skiing. And when I'm not in the Bytewax Slack, where I spend most of my waking hours, I'm in Santa Cruz. And if you're ever in Santa Cruz and you want to grab a coffee, hit me up on LinkedIn. All right, so back to our problem about stale data. How do we solve this? This is what we're going to talk about today. So we're going to talk about solving that problem. We're going to talk about how we can do it with retrieval augmented generation. We'll talk about what a little thing called an embedding is. And then we're going to do a technical implementation of how we would make a pipeline to serve real-time data in a retrieval augmented generation system, powered system. So to solve our stale problem, we have 3 ways that we can kind of do this. One is retrieval augmented generation, where we're essentially finding the most up-to-date or relevant information about the question being asked, and we're shoving that into the model prompt, and then the model should generate what we want. You could also fine-tune a model. I mean, all of you probably know all this. You could fine-tune a model with up-to-date or relevant information so that it is available for retrieval in some way, shape, or form. You could also retrain the entire model. And so when you see the cutoff that I showed in that photo, it was like a new model that had been trained with the cutoff, I think, of April or something like that in 2023, which prior, I think it was like 2022 or 2021. Anyway, if you know about the models they train or they retrain, it's quite expensive and takes like way more compute resources than I have at my fingertips. So retrieval augmented generation is what we're going to talk about today, and how you too can get rich building RAG-powered AI applications. No, not actually, but I don't know. I thought I was being a little bit funny by making this headline. So we're going to talk about RAG. So what is RAG? How does it work? As I kind of touched on, you're going to get a query, hey, I want to know something about something, or explain to me something. And you're going to go out and you're going to retrieve what you hope is the most relevant information. Then you're going to combine that query and sort of instruct the model to say, hey, this is the context you have, please answer this. Then your large language model would provide or generate the response, and you'd send that back to your user. So in order for us to go any further here, we need to talk a little bit about embedding. So we want to be able to store some information in a retrievable place, whether that be a vector DB or not. One good way to, and we want to be able to compare a question that's being asked to this information that's stored in a reasonable way and retrieve that so that we can then shove it in front of the model. One really nice way to do this is the embeddings. So embeddings are a way to essentially take things and turn them into numbers. So in our case, we're taking sentences, or you could take words or sentences or paragraphs and turn them into an array of numbers between 0 and 1. So here we can compare a cotton-made maritime shirt, which is apparently really close to a striped blue shirt made from cotton. I don't know what they would call my shirt, but I don't think it's a maritime shirt. But the embeddings allow us to compare how close those are in the vector space, so we can more easily retrieve the data. Okay, so adding to our little diagram we saw before, in order for us to retrieve, we could use Bing search or Google search or some other search mechanism, or we could, with the user's request, we could put a document in front of it, and that's sort of what the new capabilities released in the OpenAI Dev Day, that's the approach you would use there. But what we want to have here is a separate, like, asynchronous pipeline, so we're not like going to force the user to provide us with the context before we answer them. We want to be able to have all that context in this vector database. So we're going to write an ingestion pipeline where we're going to be retrieving data from a real-time data source or near real-time data source, one that is topical. And we're going to put that in a vector database. And then in theory, we would be able to make the rest of our AI application where we can take the user's query, create an embedding from that, and then use the vector database to compare how similar the information is that we want to retrieve from the vector database, and then we'll put it inside in the context, put the context inside the prompt that goes to the large language model. For this example that I'm now going to go to the more exciting part where we get a look at code, we're going to use a data source where you probably all either look at it on a regular daily basis, or you maybe contribute to it, who knows. So maybe we'll be looking at something that you've recently put on it, and it's Hacker News. So Hacker News has a really fun API, if you've never used it, where you can actually get, well, you can do a bunch of things, but one of the things you can do is you can request the max item ID. So we're going to kind of turn this API into a stream of new stories and new comments, and then we're going to analyze those. So this is where the real-time part comes in. It's not necessarily that all of these are new real-time data sources, but they are going to be trending in some sense. We're going to use that to our advantage, and so we're going to take all of that information and we're going to put that in the vector database, and then we would be able to query, say, what is the cool new trending database, and it would probably tell us something about a vector database or something. To do this, I'm going to now introduce Bytewax, because I think this is probably a good time to do that. So Bytewax is a stateful stream processor, and it's a data parallel by nature. So if you don't know what that means, essentially it's a way to process data where you decided to do things where the data is split and then is worked on independently, instead of all the tasks are split and then you send the data there. But more importantly for us, it has a Python native API, so we can use the whole suite of tools that's provided in the Python ecosystem. It runs on top of a Rust engine, which is called Timely Data Flow, and we've kind of built on top of that a bunch of things you need to run this in production. With a stateful stream processor, you can do fun things like windowing, aggregations, joins, etc. We've focused on trying to make something that was really extensible and also developer friendly, so it's pretty easy to get started. Just pip install Bytewax, and then you're ready to go. We've created a input API, so you can basically connect to almost any data source, and you can still get some of the things you might eventually want, like being able to partition across, or being able to split the input across multiple partitions, being able to recover from offsets and those sort of things. Okay, so at the very highest level, when you write a Bytewax data flow, is what we call it. So when you use the API to describe an input, some transformations that are happening in operators, and an output, you've created a DAG. So that's what we're going to do. So we're going to make a directed graph where we're going to get some input from Hacker News, and then we're going to do some initial processing. Then we'll use some of the Python ecosystem to further process the documents, create the embeddings, and then we'll put them into Redis in this case. We're going to use that like vector capability of Redis. So the part of this that is the Bytewax part, because I've had this question before, is it's the API to describe these. So there are a bunch of operators. The operators basically control the flow, and then you use Python code inside the operators to do the transformations. So you could think of these nodes in the graph. They're all operators where you could do things like split or join or windows, et cetera, or just a map, and then you pass Python code to do the actual transformation. So I mentioned about our input API, so we'll just take a quickish look. Better look at the time. On what the Hacker News input class that we're going to build, that's going to be our input connector, that's going to pull Hacker News in real time. We're going to take advantage of that max item ID. So essentially, oh, sorry, I need to go to code here. Okay, is this easy to see? What happens if I click that? There we go. Okay, so I know it's sometimes you're like, oh, what am I looking at? What am I looking at? So when you're writing connectors for some framework to process data, you need to be able to describe how the data is split up and then how you want to recurringly ingest the data. And so with Bytewax, you have two parts here. So one is your partitioned input class, and that's where you describe like, hey, worker 1, you're going to look at these parts. Hey, worker 2, you're going to look at these parts. And so that's called initially, and then that returns the next part, which is the actual data source part, and that's where you instruct Bytewax, hey, every X number of seconds or milliseconds, I want you to like pull this thing and receive this data, and then when you receive that data, shove it downstream, and then I'm going to do things to it. So in this instance, we've basically created our class, our like HN input class will receive like an interval, a line 2, and then an initial ID. And we'll ignore the initial ID, but the interval is essentially the polling mechanism. So if you ever use Kafka or other systems where you're consuming from a streaming system, you're basically like repeatedly polling and requesting data, the new data that's arrived. So in this case, we're polling every 15 seconds, and then we're going to get a new max ID, and then we're going to say, hey, I've received this new ID. The last one was this ID. I want you to send downstream all these IDs. And now we have a stream of IDs we've received downstream. There's a lot of streams there. Okay, so we've written this little Hacker News input, or we've described how the input looks for this Hacker News input connector, and now we're going to do some initial processing. So what we've received at this point is a stream of IDs, and you're like, that's cool, we can't do anything with a stream of IDs, it's not going to make our RAG application. So we need to do something interesting here to enrich, and then we can then do some pre-processing on those IDs. I did have them as, I think it's this one. Okay, so before I go any further, I mentioned that things where you had this idea of an operator and you describe this like flow of data through a data flow. And so that's what this looks like here. And this is that DAG I mentioned. So we have a number of steps. We're essentially describing what we want to happen. So we're going to have like an input, then we're going to redistribute it across workers, which I won't get into right here, but basically if more workers than you have partitions, you can now split that across as many as you need. So if we have network constraints or whatever, we can have many requests going on. We're then going to, oops, hopefully there's a cache there. Okay. We're then going to use a map operator, and this is that like pre-processing I was cutting out here. So we're going to do some enrichment. We have, if you remember, we have the stream of IDs coming through. Now we're going to take the ID and we're going to get the actual metadata associated with what's the URL, who wrote it, et cetera. And then we're going to take that and we're going to filter out to just stories, because if you've used the API before, you get polls, you get comments, you get stories. We only want the stories right now. And then from that story metadata, we have the URL, and we're going to receive, or then we're going to request for the URL. So that's what's happening here. And I won't get into all the details here, but you can just imagine that, hey, we've successfully received the stream of IDs, and now we know which ones are stories, and we're going to go get the URL, and now we have this blob of HTML. And you're like, that's sweet. I have a 60,000 token like HTML blob. What the hell am I going to do with that? So we have to write another little capability into this, which we're going to talk about next, that we can process that HTML. So if you've ever worked with raw HTML from like a request of a web page, it can be just an absolute pain to deal with. You'll have like a bunch of JavaScript stuff like stuffed in there, weird HTML tags, all these CSS classes they made up, and it makes absolutely no sense. And so we're going to use unstructured, because one of the things that's cool, in my opinion, and I'm not biased at all, about Bytewax is you can use that like entire suite of Python, of the Python ecosystem. And there's literally a library for everything in Python, especially when you talk about data. So unstructured.io has a package called unstructured. And I think unstructured, and they have some really cool functionality you can do here, where you can essentially ask them to like split up the HTML, and then they'll do some work and they'll like tag different things into different like texts. So you can have narrative text and you can have other descriptors on it. And so we can return that narrative text only, and we'll basically just get the stuff we want. The next thing we have to do is chunk that up, so we can use them. You can use unstructured to also like chunk that data up, and the reason we need to chunk it is because the data could, the like text you end up with after you've parsed this HTML, if that's bigger than the window, or sorry, the size of the embedding, so you can't actually take that text and turn it into a representation. You need to split it up in a smart way, and there's a lot of like thought that goes into how you split that up, and I'm not going to go into that because I don't work on that at all, but luckily people have figured out how you can do that intelligently. So you split that text up, and then we're going to send all that downstream. So at this point, thanks to unstructured and other capabilities, so we reached out to Hacker News and we're like, what's the latest ID? Now we have a stream of IDs. We send that stream of IDs downstream, and now we took those IDs and we enriched them by retrieving metadata from the API, which included a URL. We then requested from that URL the entire HTML. We took that HTML and we processed it with unstructured, and now we have chunks of text associated with an article URL, which is associated with an article ID, and that article ID is tied to that initial ID that we got from Hacker News. At this point in time, we want to take those chunks of text and we want to turn them into a vector, and then we'll be able to use the Redis connector to write those out to a vector database. And those would be able to be retrieved in our application. Okay, so in order to create an embedding, we're going to use a model available on Hugging Face. And that is also going to be quite easy. It's actually the easy part of the whole thing, because someone else did all the hard work for us on this one, just like Unstructured did. This is another step in the flow. Wait, that's the wrong one. So I really got to stop clicking on things. All right, so we went through the flow, we have the document, and now what we're doing is we're looking at the embedding. So we're providing a model, PyTorch class, length of our vector dimensions, which has to map up with our Redis vector length, and then the tokenizer. So we send that to this function, little function I wrote, but it's essentially, we're going to use Hugging Face transformers to kind of turn our text, our chunk of text, into the vector. So we'll kind of skip over that part a little bit, and then we'll get on to the last piece. Okay, so the last part of this, we've gone from IDs to URLs to HTML to chunks of text, from chunks of text to vectors. Now we need to put our vectors into the vector database. In order to do that, we need to provide the database with some information on what we're going to be storing. So we're going to be storing the metadata plus those vectors, and we're going to store it in a way such that we can kind of retrieve potentially all of the information associated with the chunk of text. Because if we think back to the chunked text, it doesn't necessarily represent the entire document, and we might want that whole document because there might be a lot of information that we need about that. So we'll just store our stuff in Redis with an identifier that says, hey, this is the item ID, and then this is the part of it, and then in that way we can actually retrieve all the parts. So I wrote a little Redis connector. All right, so Redis has a library called Redis VL, which makes it easy to use their vector. I guess it stands for vector library or something like that. I don't know. Yeah, it makes it easier to use the vector part of their vector database. It's really straightforward. There's similarly to the input API, you basically tell the worker, hey, we're starting this worker. You got to do this first, and then with each new batch of data, I want you to do that. So we've written that here. We said, hey, I'm starting that worker. I have a schema. Go connect to Redis. Let me know if the schema exists. If I want you to overwrite it. And then it's going to run this. Bytewax will run this. When I say it's, I mean Bytewax. Will run this build. Oh, really bad. Poor etiquette here. I don't think I can even get back to what I was talking about. Maybe. Nope. Well, I actually might have the code somewhere else, but hopefully this works. No. Okay, so the last part of that was writing the batches. So we've connected, we've said, Redis, you have this thing, don't override it. Now we have this handler that says every time we get new data in the stream, that's a batch of data, I want you to go out and, I'm just going to talk about it and ignore that. We can put this so it's nicer to look at. I want you to go out and do whatever I put in the right batch. And in this case, it was like, go write it into the vector database. So we have the data in the right format that the schema is set at, and then we're good to go. So every time we receive a new batch of chunks of text, we'll write that batch out. And that's it. I had this thing running, but since I lost, it's gonna panic. But you can see what's happening here. So we're asking Hacker News for the IDs. We receive the IDs. We send them downstream. In the code I showed, there was an inspect, where I'm logging this out. So that's what you're seeing here. So basically, this is a comment, so ignore it, a comment, ignore it. At some point, we received an actual story. Looks like this is a story here, and so we have the text, and then we'll have, oh no, that was a giant comment too. So there we go. So we had a little story. It was really short. Once we pulled it, looks like a transcript and subtitles. You can see the text here, and then you can see this is the embedding, but it's byte string. That's what Redis required. So you can see a byte string list basically here, and then it failed. But this was running in the background when I was sitting at my booth there. So we loaded up this Redis database. I won't press anything here because I don't want it to go away on me. But you can see here that we've shoved this database full of vectors. So the next step that we would do is when we're writing the application to interact with this vector database where we've created an ingestion pipeline running in the background. In this case, it's like, we're going to ask funny questions like this comparison of common Lisp testing frameworks. This is like a proper little Hacker News piece right here. So we would be able to reason about things like that, and especially if they were really trending. Like I'm sure there was like 6 or 7 things about the OpenAI Dev Day a week and a half ago or whenever that was. And the way that last piece works is like you'll have to take the request and turn that into an embedding, and then you're going to compare those embeddings in the vector space, and it will return ones that are similar, and you can rank them, and there's other things you can do there, but that's outside of the scope of this talk, and then you'll use that in the prompt. So this is the document embedding for this one, which shows up as funky little bytes there, and then you can see all the other metadata. So in this instance, so we have key ID. So if we went back to the code, which is probably not in existence anymore, the key ID represents the item, so that's like the story, and then the chunk. So what we could do, which is kind of fun, is like, so the story's 12 chunks long. If you were just using a straight vector retrieval, this might not have this optionality, but we could actually do some sort of like regex search where we could find the top story, and then we could retrieve all the chunks, because not all the chunks will match potentially, but you might want all the chunks and string them together and put that in the context. Yeah, that's all I got for today. Thanks everyone for listening. Yeah, if you would like to give us a star on GitHub, that would be really helpful. Thank you. I think I have some time for questions. I think 3 minutes. So if you have any questions, I can take them here. Otherwise, I'll be at the Q&A table, and then I'll also be at my booth pour over coffee.
Thank you. I was trying to understand how Bytewax is different from another stream processor. Is it particularly tuned to this embedding?
Sorry, I didn't hear the last part. It's different.
Is it particularly tuned to the embedding process, or is it generic?
No. So Bytewax is just like a generally applicable framework and processing engine. So you can think of it kind of like a Flink or alternative that allows you to use Python native code without all the things, and it doesn't require you to learn about a new scheduler or task manager or job manager or anything like that.
Yeah, just like a quick question. I noticed you used like Redis for the embedding store. Why not like Pinecone or like some, as a service thing, and you decided to go like for a locally deployed Redis? Just curious.
Yeah, you could use whatever you want. There's a Pinecone Python SDK, I think, or it's just an API call, I'm not sure. So you could use that, and it would be the exact same pipeline. You just swap out that last bit. So the last line there was, you could do quadrant. You could use. So this last line here is the output. So I wrote a Redis vector output class. So that's the connector there. But you could use whatever you want. We don't have a massive library of connectors, but we will in the future. We're going to have like a connector hub, if you will. So you'll be able to, there will be a Redis one, a Quadrant one, Elasticsearch one, and then on the input side, there's Kafka now, Red Panda, and there will be all these different connectors. We've kept that out of the library for now just to focus on more core problems. But so I know Brian, who's a developer advocate at Redis, and I told him like, hey, I'll do Redis in this one. But I had Quadrant before, and you could use whichever you want.
Good, yeah, makes sense, thank you.
Yeah, of course. I think that's it for time.
Indeed. Thank you.
Thanks, everyone.